In Chapter 7, we'll be looking at something referred to as radical expressions, not to be confused with rational expressions. Those are Chapter 6. Those are things in fraction form. Radical expressions are things that involve this symbol that we would call, also known as a root. So we deal with square roots, cube roots, etc. You may have some experience with some of those, but we'll be taking those understandings a bit further with additional notation and properties and rules. So the idea, to generalize it, to say the nth root of something, nth root of a here. The idea, the nth root of a is equal to a number such that that number, if you raised it to the nth power, would give you the number inside of that radical symbol. So, real quickly, here's some terminology. The n is referred to as the index of the root or the index of the radical, and the number on the inside, the term on the inside, is referred to as the radicand. I'll quite often refer to this as the inside, but the official name for it is the radicand for the radical. And so again, to that definition, the understanding of the second root of 25, because the 2 is always implied here. This is an index we do not use, a 2. And also can be referred to more commonly as the square root, just like 2 as a power is referred to as the cubed root. And so this second root of 25, or square root of 25, we would say the square root of 25 is 5, and I'll write since 5 squared is 25. Again, the implied index there is a 2, and so we're saying the second root of 25 is 5 because 5 would be the number you would square to get 25. Similar here, the third root of 8, which also can be referred to as the cubed root, just like a power of 3 is a cube. The cubed root of 8 is actually the number 2, since 2 is the number you cube to get 8. So that's how we're going to interpret these radicals and the indexes on the radicals and the radicands. So just a couple more quick computations there on some smaller numbers. Here we've got the square root of 100. So again, we're essentially asking, what number do you square, right? What squared give you 100? Well, the answer is 10. So the square root of 100 is 10. Here, cubed root of 27. We want the number you would cube to get 27, and that would be 3. 3 cubed is 27, so the cubed root of 27 is 3. And the fourth root of 16, maybe not as familiar with your fourth powers perhaps, but we're asking the thing to the fourth to give you 16. And you'll learn as you just work through numbers that as these exponents and thus these indices get bigger, these numbers grow very quickly. So the number to the fourth power to be 16 is going to be a small number. Turns out it's 2. 2 to the fourth is 16. Okay? Now, as the radicand gets much larger, this becomes something that you aren't definitely expected to do, in your head. And there are approaches that we will use to finding them. One approach would just be to take any number, I'll go back to this 27, and just start breaking it down using a prime factorization tree. Think of any two numbers that give you 27, in this case 3 and 9. You can break 9 down to 3 and 3 until you have all of the prime numbers, and you can go from there to say, oh look, 27 is 3 times 3 times 3, right, which is 3 cubed. So if you don't know your cubes or your fourths, then certainly utilize a prime factorization tree to start breaking these larger numbers down. Again, that will come in even more handy a little later on in a later section as well. Now, real quickly, let's talk about this though. We've got a square root of -4. I'm asking you, what would you square to get -4? Well, in our real number system, such a number does not exist, right? Because to square a number would mean take it times itself. And whether you take a positive number times itself or a negative number times itself, you don't get a negative answer. You only would get positive answers. So we can extend that a little further and say that when you have an nth root of a, where a is any negative number, if n is anything even at all, whether it's square root, fourth root, sixth root, right? If n is any even number, then the result would not be a real number, right? Nothing that we know of in the real number system could be raised to an even power and give you a negative value. Now, odd powers, it's fine. Odd indices are fine. We can actually potentially work with that. We will do more with this. We will elaborate on this not a real number eventually in this chapter. That'll actually come in the next exams material, or after this exams material, but we will expand on that. For right now, though, this is the idea. So, looking at this one, cubed root of -8. Notice we have a negative on the inside, but n is odd. So we're asking you, what would you cube to get -8? And in fact, 8 itself is 2 cubed, and so we actually could say that this would be a -2. Because if I said -2 cubed, that's -2 times -2 times -2, we would get a -8. This is why the odd indices are okay, because odd powers leave you that one additional negative to be able to obtain a negative result. So that is absolutely doable. Now the next one, the fourth root of -81. 81 itself has a fourth root. It's 3. However, a negative inside of a radical with an even index, this is an example of not a real number. And real should probably be capitalized, but that's an example where we cannot currently evaluate that. Now, that's not to be confused with this, with a negative on the outside. Here, you've got the square root of 16, so the number you square to get 16 is 4, and the negative sitting out front would give you a result of -4. That is certainly something we can compute.